In this video, we are going to look into the Pandas Dataframe. We call this Dataframe data structure as the heart of Pandas library. This is one of the main objects where we will be working for performing the data analysis and data cleaning. For easy understanding, you can think of Pandas Dataframe as an in-memory representation of an Excel sheet via Python programming language. It will have some index, multiple columns of data, and each column is having some label associated with it. Let's create a data frame to get a hang of it. As you might have guessed, we can create a data frame in many different ways. For instance, we can use a group of series where each series represents a row of data. Or we can make use of group of dictionaries where we can have each dictionary representing a row of data. Let me write the code to illustrate this. So I'll create some group of series using the dictionary. Let's say I'm creating a person's age, name, and their designation. So first I'll import pandas as PD. Now I'll create the series using the dictionaries like this. Now we are going to pass this series into a data frame as the first argument, and then we are going to pass the index values indicating the company for which they work for. Now, if I print the data frame which I have just created, we can see that the Jupyter notebook has printed the data frame as a table. Just like we have seen in series, we can extract the data using the iLock and the lock attributes. Suppose I want to display the details of people who work in Microsoft, then I'll pass in like this. As we can see, we have got the output of columns with index equal to Microsoft, and also the name of index is displayed like this. We can also make use of iLock attribute to query the value at the specified index. Let's say I want to extract the name Phil from this data frame. So I'll pass in the value as df.ilock1,0 and run the code. As we can see in the output, the program has returned the value as Phil. We can check the data type of the return. One thing we need to remember is the indices and the column names along the either axis, horizontal or vertical, can be non-unique. For example, if I want to extract the names of people working at Google, so df.lock of Google, so this has returned two values. Another important feature of Pandas data frame is that we can quickly select the data based on multiple axes. For example, if we want to just list the age for Google, we would simply pass the two parameters to .lock. One parameter referring the row index and the other being the column name. So we can write this as df.lock Google, age. Now let's say we just want to list only the designation of all the indexes. To do that, we have some options. First, we get the transpose of the data frame using the capital T attribute. So this would swap all the rows and columns. And this essentially turns our column names into indices. We can then make use of .lock method to display the designation. As we can see, this works. These .lock and iLock are used for row selection. But we can directly pass in the column label for the particular column selection. So to select all the elements in the column designation, I can pass the column label directly like this within the square bracket. We can also chain the operations together. For example, if I just want to query for the Google company with their age, then I can write it like this. Even though the result we got is good, but sometimes chaining comes with a cost, and it is best avoided if it is possible to use another approach. Sometimes what happens is that chaining tends to cause the pandas to return a copy of the data frame instead of a view on the data frame. When we are selecting the data, this won't be an issue. At max, it may be slower than necessary, but when we are changing the data, this is an important distinction and it can be source of error. So, till now we saw that .log can have two parameters, where the first parameter takes the row index and the second parameter takes the column names. The .log also supports slicing. So, if I want to select all the rows, then I can make use of colon to indicate a full slice from beginning to end. And then we can add the column name as the second parameter as a string. This is an example. Suppose I want to select all the rows and display their designation and age, then I'll pass in like this. Here I have included the multiple column names in a list, and we have a required output. So in this way, we select and project the data from Dataframe. Now that we are learning about accessing the data, let's look about dropping the data. It is very easy to delete the data in series and data frames. For that, we just make use of drop function. The drop function takes a single parameter, which is the index or the row label to drop. Suppose I want to remove the row which has the index as Google, then I'll pass in like this: df.drop Google. If you're new to Pandas, then I want you to know this. Whenever we make use of drop function, it will not modify the data frame. It will just return the copy of the data frame with the rows removed. If I display my original data frame, the row Google is still intact. And we make use of copy method to copy a data frame. The drop function has two interesting optional parameters. The first is called inPlace. If it is set as true, then the data frame will be updated in place instead of a copy being returned. The second parameter is the axis, that is mentioning as which should be dropped. By default, this value is set as 0, and that means row axis. But if you want to drop some items along the columns, we can change it to 1. There is a second way to drop a column. However, that is directly through the making use of indexing operator, using the del keyword. This way of dropping the data, however, takes immediate effect on the data frame and does not return a view. Finally, adding a new column to the data frame is as easy as assigning to some value. For instance, if I want to add a new location as a column with default value as none, we can do it by making use of assignment operator after the square brackets. What this will do is, this will broadcast the default value to the new column immediately.